Okay, so greetings everyone. This is 481 Computer Control Systems. My name is SOHAM SARKAR. I'll be your instructor for this course. I have been teaching this course for a couple of years now, and me and my students, have always enjoyed this course throughout the journey. But don't be fooled by the name. Don't be fooled by the name, Computer Control Systems. It does say about three terms, which is computer control and systems. We'll be talking about that. But this is an electrical subject, and the prerequisites are 2 or 3, which is signals and systems, and okay. Someone on the chat. Okay. Signals and systems, we'll be taking that approach. There will be discussions pertaining to microcontroller architectures in your first module, some of the modules, and we'll be doing some of the labs based on some of the architectures, but we'll not be entirely discussing about the architectures. We'll be using 2 microcontroller boards, and I'll talk about that as the lab proceeds. One microcontroller board to emulate the plant, the other microcontroller board to emulate the controller, if you know what the plant and a controller means. But before that, before I proceed, anyone here, they are well versed with controls class before? Okay, great. Okay, great. So even if you have not taken a controls class, or a signals and systems class, we'll be discussing the prerequisites. We'll be starting from scratch. And you have the modules. We have pre-recorded lectures where you can study the material. And we'll be going through them one by one. Today's class, especially, I'll be introducing the course structure, the syllabus, and the grading scheme, the points, how many homeworks do you have, how many quizzes you have, how many labs you have, and maybe if the exam at the end that you have. We'll be talking about that a little bit. I know the material seems to have so many assignments, but me and the TAs, we have always helped in the past. And I do urge you to ask and bug us by asking as many questions as possible. And don't be shy of asking any question. If you feel embarrassed that it's a stupid question, we all have started by asking stupid questions. My journey, while I was sitting at your place right now, I started by asking stupid questions, and I still do right now whenever I try to learn something. So don't be afraid of that. Please do ask me as many questions as possible. And speaking of asking questions, you have 2 forums. I do not use the community forum too much. I do urge you to use the Piazza forum. And I think you have the link given where you can enroll yourself as a student, and you have the access code given to you. So you can please enroll yourself as much as possible. Why is this helpful? Because you might have a question similar to one of your peers. So if you get your question answered, then it might help the entire class. And we are 24 hours live throughout through Piazza. And the beauty of asking questions on forums is that while you step out into the outside world, people do communicate through forums, especially while talking about hardware. This class mostly talks about the mathematical practices which we'll use. It's a math class, and we realize our mathematical expressions by using hardware. So forums have helped us develop this class. Forums have helped people working on hardware for many, many years. So I do urge you to get into the habit of helping each other through forums. So yeah, that's one of them. An important thing is that the Zoom meeting link that is given here is for the class hours as well as the virtual office hours. My virtual office hours are given on the syllabus. It's on Mondays, Tuesdays, and Thursdays. 2:30 to 3:30 p.m. And for the labs, I won't be present at the lab. My TAs would be present at the lab for the in-person students, and it will be you will have assistance in person and online. So yeah, if you have any questions regarding that, please do let me know. Also, yeah, so I'll also mention the TA office hours here. So please keep an eye on this particular part of the module. I'll add the TA office hours and their links. Mostly it will be 4 days a week, so you should have assistance, and also you will have the Piazza forums for us to answer your questions. Okay. Apart from that, regarding the TAs, yeah, I think I have that to say. Let's go through the syllabus. Okay, there are 7 modules, and each module will have a homework and a quiz. And don't be afraid of the homework, because each week we have a Wednesday class. And on those days, I'll be answering all your questions, as well as I'll be solving problems very similar to the homeworks, so that you are not really afraid or not really overwhelmed by the homeworks. So, and it's a good practice. We'll have a very good discussion, and it's a good guidance and a good template to go through the problems. Okay, so you have, for each module, you have a homework and assignment, except module 7. Module 7 just has a quiz. So you have 7 quizzes and 6 homeworks, and they are evenly placed throughout the semester. You have between 2 consecutive homeworks, you have 2 weeks of time. So go through the pre-recorded lectures, ask me questions, trouble me as much as possible. I love answering questions. And please do reach out to me via email on my office hours. And if you do not have access to certain parts of the Canvas, let me know. Okay. For module 1, okay, but before I begin, does anyone have any questions up till now? Yeah.
Yeah, regarding I saw in the announcement,
Yeah. Yeah. I'm going to talk about that. So first I'm going to talk about the modules, and then while talking about the labs, which comes after that, I'll talk about the Arduino loan form. That's pertaining to the in-person students only. So yeah, there are certain, I'll talk about that again. There are certain kits available to you, and we have few kits, about I think 15 kits or something. So reach out to us as soon as possible. If that resource depletes, you have to get your own boards. But I do suggest getting microcontroller boards for yourself if you are interested in industries, because we'll ask you to return the Arduino kit, and you need to practice on these microcontroller boards to realize what the math is speaking about. The math that you are going to learn throughout the course, you will see that you can realize that using hardware. You'll see the answers almost matching that. So it's if you do not have practical experiments to verify our math will have no meaning. So that's why we have these practices available. Yeah.
Your in-person office hours, where are those located?
So I do not have in-person office hours. I have virtual office.
Tuesday, 2:30 to 3:30?
Yeah, I'll have those via Zoom.
Oh, both, I think. Okay.
Both by Zoom, yeah. And you can also reach out to me via appointment at any time. So, yeah. Okay, let me go through the modules. These are textbooks given to you. You do not have to delve into the textbooks too much. You can. I would suggest you to go through that. But if you can totally depend on the pre-recorded video lectures, because I know you have a lot of courses, a lot of assignments from the other classes. I do not want to put too much pressure on you guys. So depending on the pre-recorded lectures, which are interesting, they get you hooked all the time. So, so you can go through that, complete them, and then you can ask as many questions to me as much as possible. Okay, for module 1, we go through some of the introductory concepts like a feedback loop. They introduce the feedback loop and then why MATLAB and Simulink is helpful. What are the different kind of embedded computers? What are the different kind of protocols, communication protocols between digital systems? So if you are going to communicate between one microcontroller board and the other microcontroller board, there are certain communication protocols that have been used throughout a long time. So, we'll introduce that to you. NVIDIA uses certain protocols. There have been AT&T Bell Labs have introduced certain protocols in the past. There's so many literature regarding protocols, and in these current days, people make their own protocols for faster executions and faster communications. So for me, talking to you, I speak via certain languages. I'm talking about for me to understand you and for you to understand me, I'm talking at a constant rate, and I'm using a language that is common to both of us. So that's why you are able to understand me. If I try to speak very fast, it will not be so easy for you guys to understand what I'm saying. Also, if I were to speak on a different language, it will be difficult for others. So we are following protocols right here. So even microcontrollers and computers, they follow the same methodology. And we'll discuss that through as we proceed while discussing the assignments. Okay. More important thing that will be introduced are digital and analog systems. Analog systems are very similar to continuous time systems. Digital systems are very similar to discrete time systems. So while you have a microcontroller board that computes things digitally, and so while the math that you will be doing, that will be computed in analog. So for analog and to digital conversion, or in other words, to realize the math, you will face certain errors. The mathematical answers that you have, while verifying them digitally, you will see that they will contain some errors because we do approximation while discretizing the systems. And so our job is to identify what kind of errors we receive and to mitigate them as much as possible. So it's not totally possible to mitigate the entire error because the process that I'm talking about is called quantization. That is analog to digital conversion. And it comes up with these demons called errors. And so people nowadays have mitigated them as much as possible, but this class is to talk about these errors and talk about certain practices to make them as efficient and reduce them as much as possible. Okay, now as I have introduced the topic about continuous time systems and discrete time systems, let's go to module 2, which talks about continuous time systems. Now, what is a beautiful example of differentiating between a continuous time system and a discrete time system? Usually you will see me using certain examples from the class itself. Think about the classroom right here and think about the people on Zoom. Let's assume that you have infinite frame rate in your eyes. So you can see me on real time. I move my hand too fast, you can see me not having any glitch in the system. So what you see here is a continuous time system. Whereas people on Zoom, if they can see me or if they can see you on screen, they're bounded or restricted by a frame rate, which is used by Zoom. So that's one of the examples where you can differentiate between a continuous time system and a discrete time system. And we talk, this is one of the examples, but we'll be talking about various other examples. Everything that you see around, I mean, when you use your eyes, is a continuous time system. But while computing information, you deal with discrete time systems all the time. So application-wise, we always deal with discrete time systems. But if your processor speed is fast, is nowadays NVIDIA is coming up with faster processors. So I think at some point of time, it's not realizable, but at some point of time, you might have infinite frame rate. So I mean, close to infinite, very high frame rate. So you can call them close to continuous time systems. So keeping this theory in mind, we'll be taking certain nonlinear examples of continuous time systems. And nonlinear systems are everything that you see around you right now. The resistors in these lamps, the transistors on each of these electronic devices, they have nonlinear equations running them. So our job is to understand this nonlinear, take these nonlinear examples, linearize them. We'll talk about certain linearization procedures, and we'll reduce them to a mathematical expression that is very well versed and very easy to interpret and use. It has a high utility called a transfer function. We define that term as a transfer function. And we'll be using that to analyze whether the system is stable or whether the system is unstable. And it also provides a metric saying how stable the system might be. So in a nutshell, in module 2, we'll be talking about how we can take a nonlinear system and gain certain important nonlinear continuous time system and gain certain important bullet points from it. So that's about module 2. Module 3 is where the real game begins. Module 3 is where you you learn about certain controllers. I think module 3 will talk about the PID designs. We'll design a PID controller for the plant that we have taken. And we'll try to see how stable the controller makes the plant in this process. For those who don't know what a controller and a plant is, let me do a small example. Okay. This is, I think I should move this up. Yeah. So this is the conventional feedback loop that people have been using for so many years. We'll study the nominal feedback. We call this the nominal feedback loop. We'll be studying the nominal or the conventional feedback loop very thoroughly. What this feedback loop states is that, so let's think of a plant. Let's think of this class at this point. Think of the students here, every one of you. Every one of you here is the plant. The input in this case is the course material, the pre-recorded lectures that I give you. And the output that you have in this case is an assignment or the assignments that you submit. Now, in this case, I'm the controller. I'll be giving you the resources. So let's say you as the input to the plant. I'll be giving you the course material. You are the plant, you produce certain outputs, which are the assignments. Now the assignments, if they match with the rubric, or assignments, if the matches with the correct answer, which is the reference, then we have no error. If there is some error, then we are going to penalize a little bit. And so that you understand from your errors and you improve yourself. So that's what a feedback loop is. I'm taking feedback from your assignments, and I'm using that, or you are using that actually, to help yourself see whether you have made any mistakes or not. You're improving yourself over time. Now, this does not go in one way, it goes both ways. Think about me as a plant. Now, I'm taking certain input as certain feedback comments. Okay, you did not teach well. You did teach well. So these are certain feedback comments or inputs that you are going to give me. Me understanding these feedback from you, in this case, you are the controller, I am the plant. I'm getting certain inputs that is that, okay, how did I teach? And which is your feedback. And I'm going to produce certain outputs of how I'm going to teach after that, which is my output. And that will match with the certain reference ideal ways of teaching. And you are going to, that is going to produce certain errors and you will give me a feedback again. So that's how a teaching model improves over time throughout the year. So please do not forget to give me feedback regarding how I teach. So it works both ways. So is that a little bit helpful regarding what is a controller and a plant? Okay, good. There I'll use a lot of examples regarding a controller and a plant, but I think for introducing the class, this is one example I've chosen. Okay, so let's move on. So for module 3, as I said, we'll be designing certain controllers to make the plant stable. And we'll see how stable the plant is by using certain methods, the methods being Bode plots, Nyquist plots, root locus. And I'll go through more detail than you have in the pre-recorded lectures during my class lectures. I'll go through certain more examples of for drawing Bode plots, for going through root locus and Nyquist plots. So that you have a well-versed knowledge of how to analyze and see how much stable a system is. Okay, that's a continuous time discussion that we had a little bit. Module 4 discusses about discrete time systems. Now, again, we'll introduce what's a discrete time system, we'll take a nonlinear system, and we'll realize a discrete time transfer function out of it, which has a high utility. And we are going to see whether it's stable or unstable. You are going to use certain tools to analyze whether the system is stable or unstable. So via math. And then, of course, in the labs, you can realize that through experiments digitally, whether it's stable or unstable. Okay. Module 5 discusses about certain sample rates of how you, like the frame rate I was talking about. People in Zoom, they are seeing you at a bounded frame rate. So that means the system is sampling the frames at a certain refresh rate. So how do we sample frame rates? So we'll talk about that on module 5. We'll also discuss certain alternate representations of transfer functions or of any controller and a plant. Different alternate expressions like the state space representations. And these are state space representations makes things far more easier. One, because it helps us talk about controllability, observability. It helps us to recursively find how the system output looks like. And MATLAB and Simulink actually uses state space representations to see how, if you take one particular transfer function, if you convert that into state space representation, you can see how the output looks like. So we'll discuss about different representations on module 5. Module 6, again, is analogous to module 3. We design a PID controller pertaining to your plant, and we'll also discuss different other controllers apart from PID, and we'll be seeing how stable the controller is. Okay, so module 6 is very similar to module 3. So if you are well versed with module 1, 2, 3 itself, the job becomes far more easier for you for module 4, 5, and 6. Okay, I'm going to pause a little bit here. Does anyone have any questions? Okay. Okay, let's move to module 7. Module 7 again is, we'll talk about certain advanced topics. Like now we talked about a controller, which is the PID controller. We'll talk about advanced controller called the linear quadratic regulator. Also, we'll talk about sensors the information that you see, is it accurate for the people seeing on Zoom? Whether whatever you're seeing right now, you're the observer right now. So if an observer tells us whether we are seeing things accurately or not, whether the people you're seeing on the class, if the camera has certain problems, you might be seeing different images apart from the real image. So it might not match with the ground truth. Now, if sensors are the eyes, ears of the system. So if your eyes and ears are not working, then you might not be able to do the task properly. So you need to make sure the observers or your eyes and ears are working efficiently. So we'll be talking about observers. One famous observer that has been used for a long time in also in the moon landing, the first moon landing that was done. It's known as Kalman filter. It has been used and it has been in practice for a lot of years, and it has its own pros and cons, and we'll talk about that. And also at the end we'll talk about practices of how sometimes models come with uncertainties, and all this while I was talking about linearized procedures. You will use a linearization procedure to take a nonlinear system and find the transfer function out of it. There are alternate procedures like system identification. You can take the input and output of a system and you can find the transfer function from it. Because now, not all systems can be realized mathematically via nonlinear equations. If apart from that, if you take an input and output of a system, for example, if you take the input of the light out here, which is the electric current going into this light bulb, and the output is the amount of brightness you are getting right here, then observing these inputs and outputs, you can find the transfer function of the light bulb or the electric board circuit that is helping the light bulb glow. So that makes our job far more easier. You do not have to compute mathematically. You do not have to use very complicated mathematical expressions throughout the work. It takes a lot of time. So sometimes system identification really cuts your time a lot. Okay, so these are all the modules. These are certain interesting things that we'll be talking about. Okay, and you will have homeworks pertaining to all of these except module 7. So as I talked about, 6 homeworks, 7 quizzes. Let me go to the labs right now. Let me remove this. Okay. Okay, great. Yeah, I think I have I've been through all the modules. Yeah. As you can see that all the homeworks have 2 weeks between them, so you have a lot of time. So don't be overwhelmed, and I'll be discussing the examples pertaining to the homeworks, very similar to the homework. So you'll have a lot of guidance throughout the journey. So don't be scared by them. Now for the labs, I would like you to take things seriously regarding the labs. The labs, you have instructions given to you regarding how to get started. The most important thing that I would urge everyone, so that your journey is very easy, is to use a Windows OS for the labs. Please don't use a Mac OS. It's going to be very difficult for you to identify the ports. And I am well versed with the errors. Any errors thrown in my way, I have seen, all these years, I think I'm well versed with the errors, the amount of errors that you're going to get, the different kinds of errors, and I can help you guide towards, okay, what should you do to make your experiment work? So make sure you use a Windows OS. Make sure you have 2 ports in your computers, 1 port for one of the microcontroller, the other port for the other controller. And You can use a doc as well as if you can identify the ports by using the doc, it's good enough. Okay. Now here it talks about the bill of materials, the equipment that you need to get for the labs. So make sure you go through it. And an important thing now that you need to do here is download the 481 library. You need to download MATLAB, Simulink, all the packages that you have, all the toolboxes pertaining, which is a control toolbox, navigation toolbox, and I think system identification toolbox if you need. But mostly controls toolbox is more than enough. And yeah, you need to download the library that you are seeing here. This library is very important for your experiments to run. We have designed the library so that, yeah, you once you have the plant mathematical expression figured out and the controller mathematical expression figured out, it becomes very easy for you to use this framework and get your experiments working. So make sure you download the library, 481 library right here. You have the instructions given of how to add a folder to this. And each time you run an experiment, make sure your MATLAB path has this library. And I'll do a walkthrough on this when I in your consecutive class lectures on Wednesday. I'll introduce certain walkthroughs of the experiment, taking two Arduino boards, how it's working, how the experiment is done, how you're investigating the output, how you're investigating the mathematical expression that you have right there. What are the pros and cons of the experiment? So yeah, I'm going to go through the entire experiment for one of the labs, and then it becomes easier for you to deploy for the other labs. So yeah. Okay, so you have all the instructions. So go through the videos of how to install, how to set up the parameters. If you don't go through these videos, it will be difficult for you. I mean, I will answer you if you have any difficulties, but make sure you go through the entire modules. The entire module has intricate information available to you. Okay. Now, regarding the submission. For homeworks, I think quizzes, you have answers, you have multiple choice questions. And again, it is between two quizzes, you have 2 weeks of time. So that's there. For homeworks, I would suggest that you stick to a PDF format. You submit via PDF and make sure that your homeworks are readable by the grader. If it's not legible, if it's at this point, we expect you to present your work properly so that it becomes easy for you to submit your work to your employers after this. So it becomes a good practice. So make sure your work is legible. It's understandable by us. If it's not understandable by us, I don't think the grader will give you points. So make sure you keep that in mind. For the lab reports, there's a format that is given here. So again, following the protocols of how labs have been conducted throughout the world, each experiment has certain headings that have been used as a world protocol: aim, introduction, procedure, results, conclusion, and references. So these are the things we expect you to follow throughout. If you don't follow the lab template, there will be points removed. So make sure you strictly abide by the rules. And yeah, it really helps for people who would like to stay in academia, or you would like to write a research paper later. This format helps. The double column format of using this template really helps you write things efficiently and in an organized way. And the whole world is using this template. So I think it should be easy for you guys, and it should be really useful for you guys. Okay. Now, after you write these things, you will have certain questions in your in each of your labs. Let me go through that. Let me go through one of the labs. So let's go through lab 1. Yeah. So you see in the labs, you have question 1, question 2, question 3, question 4, and you have make sure after the references, after you write the aim, procedure, results, experiment, results, conclusion, and references. After the references, you write the answer to this question. This is to evaluate whether you have understood the experiment or not, whether you know your stuff or not. So, and these will carry points. So make sure you go through them. And uh, if you are stuck somewhere, don't be hesitant on reaching out to us via Piazza, my email, Zoom, office hours. So yeah, the entire experiment might not be uh, it might not be understandable at the first go. So you can ask me questions. Sometimes it is well versed. Um, the PDFs are quite straightforward, but I still like to criticize my own work, criticize the labs so that it becomes much more better and better. So yeah, if you have any comments regarding the labs also, do let me know. If there are any mistakes, let me know. So yeah. Okay, so as I said, there will be the double column format that you need to stick to, and you need to answer this question. And these are quite easy questions, so you should not have any problem. And yeah, do not leave out any question. Make sure you answer them as much as possible. And I'm sure like most of the questions will be perfectly understandable once you do the experiments. They are quite straightforward. So, and I'll go through lab 1 in the next classes. So I will not go through that in detail right now. Okay. So let's talk about the timings. Each month, uh, each month you have a lab. So you have a lab on February 21st, you have a lab on March 21st, and then April 6th and April 27th. So you have a lot of time between the labs. Please don't take it light, because I've seen over the past years, if you wait till the last week, it becomes very stressful for you at the end moment. You have enough time for the first lab so that you can buy your equipment. You can get started with the experiments, go through the modules, go through the videos, and you can practice them. So don't keep things at the last moment. That's my kind request to you guys, because I know you will struggle at the end. It becomes very easy once you have made the setup, especially if you are successful through lab 1. Then it becomes very easy for you to do lab 2, lab 3. And if you can do lab 2, which is a little bit difficult than lab 1, lab 3 and lab 4 is a cakewalk for you guys. So make sure you concentrate on the lab 1 and lab 2. So it's not that difficult. The entire procedure is given to you guys. And of course, we are going to help you. But yeah, don't keep things at the end moment. I'll keep on bugging you guys regarding please don't keep things at the last moment so that you don't struggle at the end. I really care a lot about my students, and so that their pain is reduced throughout the journey. Okay, that's about it regarding the labs. You will have a final exam at the end of the semester, I think most probably on 7th of May. So I think, yeah, for the online students, it'll be held on Zoom. For the in-person students, I don't know. Pertaining to certain requests, for some people, it might be held on Zoom. But I would sincerely request you guys to have the exam in person, because if anything goes glitchy in the online exam, then yeah, usually sometimes it happens and it becomes a sad story. And it hasn't happened anytime in my class, but I don't want you guys to go through that trouble. So I would request you to go through the exam in person. The course, yeah. You won't have microcontroller boards in your exam, so it will be difficult for you. Okay, so that's about the labs, the modules, the homeworks. Is there something that I'm forgetting right now? I don't think so. Oh yeah, the class meeting Zoom recordings are given in this spreadsheet. I mean, we haven't had any Zoom recordings. This is the first class. So you will have the Zoom link given here pertaining to today's class, and the passcode will be given. And if there are any remarks to be made regarding this particular lecture, I'll give those remarks. So make sure you go through the Zoom link. You go through the entire class. If you have missed something, if you have missed the class or something, but I do urge you to come to the class lectures. I won't take the entire 3 hours, depending upon the questions you have. But I'll try to wrap up as soon as possible. It might take maximum of 1 hour or 1.5 hours. So yeah, if you have, oh, I think Vatsin has a question.
Yeah.
Yes, Vatsin.
You mentioned that we can either take the kits for the Arduinos from you or buy them.
Yeah.
You, uh, are these Arduino kits or just Arduino boards?
These are by Arduino kits, I mean that there will be 2 microcontroller Arduino Duo boards, and there will be 2 USB cables and 2 connection wires. I think 4 or 5 connection wires. That's what I mean by a kit, and that is given in your bill of materials. So you will for the in-person students, you will have certain kits given to you, and we have few kits. So I would urge the others to buy them as soon as possible. And even if you have the kits handed out to us, later please buy these buy an Arduino board if you would like to practice these examples, because these are useful. Industries do ask these kind of practice. It's good to have on your resume also. So does that answer your question?
Yeah. So all I wanted to ask was if like, let's say I want to buy whatever we need for the class, right? So I
Yeah.
would only need the 2 Arduino Duo boards and some cables to connect them.
Yeah.
Okay.
Some connection wires, and then 2 USB cables to connect that to your computer.
Okay, sounds good. Thank you.
Yeah. Okay. So as I was talking about, the Zoom link will be given here in the passcode so that you can reflect on something you have missed during the class time, and also the pre-recorded lectures will help you reflect on the class material. Also, if you go through the lectures, you'll see that uh, for any one pre-recorded lecture, you have timestamps about what is being talked about. So if you have a question or if you have forgotten something, it becomes easier for you to reflect back and see what you have missed or what you don't recollect. So it makes you easier to learn and absorb material. So I hope this helps. I think that's about it. Let me go through the grading scheme once more. So this is the syllabus. As you can see, my office hours are given here. These are the lecture timings. This is the lecture room. I did talk about the modules. I won't go through them once more. Yeah, we did talk about the labs, the quizzes, the exams, and the exam is about 300 points. Let me go through the points once more. So the homeworks, as I said, 6 homeworks, 50 points each, and you have 4 labs. I've written 3 labs because for 481 you need to do 3 labs. For 591 you need to do 4 labs. The last 4th lab is also an extra credit for 481 guys. So yeah, in case you think that you might be losing some points, you have lost some points, the fourth lab might help you, and it's kind of an easy lab, so it might be useful to you guys. Okay, and these are the certain grading schemes that you can see about here. One more thing I would like to stress on is that please don't ask me to postpone a deadline pertaining to your homeworks or your labs. It's going to be very difficult, and it's not fair to the other students. So please don't ask me to postpone a deadline. I cannot do that. And make sure you submit your assignments on time. Uh, if um, um, if you are having some assignments, I think late, I think there's some, I think 20% penalty for submitting it late, something like that. Yeah, you have about 20% penalty for a late submission. So make sure you avoid any late submissions. So bug me and the TAs make us tired by asking a question. It's good for us. So so that you can get your assignment done on time. Okay. I think that's about it. I think I've been through all of that. Let me go through one of the things that a student did ask me is the Arduino loan form. Okay. There's no. Hold on a second. Yeah. So I think there's one thing I did mention is that your labs will start after 21st of January 2025. Your labs will not be available for the in-person labs. You won't be having access to them before 21st of January because they are doing something. They're doing some of the maintenance before it so that it's clean and properly done by ASU. So make sure you go to the labs after January 21st. And here are the Arduino Kit loan forms. So you need to submit to me via your identification. Submit to me or the TAs. I think it's better you submit to the TAs. Go to the labs. I'll hand over all the kits to the TA and submit this Arduino loan form to the TA. With you should have your ASU ID with you, and you should as soon as you receive the kit, mention the kit number, and you should be good to go. You can take the kit and you can start practicing it yourself. And if you don't have the kit, don't depend on the kit. Buy the Arduino microcontroller boards yourself, and then you can realize a lot of mathematical expression and interesting stuff, and you might drive a robot or a car yourself. Okay, I think that's about it. Does anyone have any questions? Oh, good. Okay. Anyone? Okay, you can start. Yeah.
So for the new person, and you go to the relay if you want after now you will be there.
Yeah, so I'm going to mention the TA hours. The TA is going to specify the hours right there. Yeah, you can always put it in. And the lab location is GWC 379. So yeah, you do have Arduino boards there, so you can use the Arduino boards. But the systems or the computers in the lab do not, I think they might not allow you to install the library or make certain changes. So don't use the computers, use your laptop in the lab. Okay. Someone, oh, okay.
Can we share the?
Huh?
Can we share the? Share with you?
Yeah, sure, we can share the kit. That's I mean, but yeah, you can share it for your so that you can work together. That's okay. That's all fine. Yes. So you won't know the kit number before. As soon as you get the kit number, you can fill up the form, you can submit it, and you're good to go. Good question. Okay.
Do you have a Mac? What would you suggest we do, like virtual machine?
Virtual machine is far better, but if
Okay.
you can borrow someone who has a Windows laptop, it's far better. So, yeah, I would strongly urge you to work on a Windows OS for now, for understanding the framework. And then you can see for different systems how to use it with a Mac. It's, I think, couple of commands, I guess, regarding that. But this framework is totally designed based on a Windows OS. So yeah, I would strongly suggest that. Okay. Yes.
Kind of having to do with somebody else on the outside of the room, so we can share the equipment or work together for the lab,
Sure.
but we might do individual reports.
No. Yeah, I strongly urge you to discuss all the labs with your fellow companion. You can work together, discuss, and you can mostly we as students, we argue with each other to learn stuff. And you can discuss how well it is working, why it is not working, and come up with a question, and will help. So I strongly urge you to work in groups to understand the experiment, see how it works or not. It's not required for you to work alone. Okay, and for writing the report, once you know you have the knowledge of the entire experiment, you need to write the reports yourself. You should not have similarity between reports. It's quite obvious, right? Yeah.
All right, thank you.
Okay, yeah.
So, will we submit the loan form after 21st or can do it like?
You don't have the kits right now, so you need to go to the lab. Once you have a kit number, you can submit the form. So after 21st. Any more questions?
Sharing we get, so only one person will be the owner.
Yeah, I think one person is owner and responsible for using the kit. So, but you can of course share the kit. It's good to, I mean, that's what we are, I strongly suggest. After you done with the class, you'll see that in the forums, people are helping each other with any expression, any questions they have in Arduino forums, in Raspberry Pi forums. People are helping out each other throughout their questions, throughout the what hardware they have, what hardware they don't have, what they should buy, what they should not buy. So getting into this habit of sharing things and actually helping each other out is a good thing. So I do urge you to share and learn from each other. Okay. Cool. And yeah, it's sad now a little bit that AI is answering a lot of questions in the forum. So a lot of users are not getting the chance, but that's why I tell my students to keep using the forums, help out each other. AI is learning things based on the answers given by users on Wikipedia, and it started with users. So users are something that AI will always depend on. So at some point, so keep contributing towards forums. This is one of the things that my previous students, me, myself, my seniors also, we keep on doing so that people can benefit from that. We'll see in Arduino forums, there are like 16 years and people in Intel have been answering questions and they love doing that. Well, if you get in the habit of that, a lot of people can learn from you and you can learn a lot from people. Okay, I think there are questions in the chat, I guess. Oh, there's no more question. Okay. Okay, I think, yeah. Are there any other questions on the online world? Okay, okay. It's been great, you guys. Do you have any questions? Oh, sorry?
I need to show you my problem.
Oh, yeah. Hold on a second. Yeah, so thank you, everyone. We'll meet next Wednesday on 4:30. And yeah, you can ask me anything on Piazza. Tomorrow, I'll not have any office hours. I'll start my office hours after 21st. I mean, next week. So, yeah.
Thank you.
I'm trying to do, I downloaded another lab, the toolbox. Then I just for the variation, this is I found XPC Explorer, it's an unrecognized function. This is I go to MATLAB.
Okay.
Yeah, I just follow the lab one. Then I type the XPC.
Oh, I guess they had a function in the lab, but that function might not be available to you. So there might be a .m file, I guess.
And we're actually downloaded from the,
You don't need the .m file. That's a customized function that
Yeah.
might have been here. But you don't need that function. XPC, I don't remember any function that you have to
no,
use for
I
that.
look at the, okay, can you look at the level one?
Oh, yeah.
So I'm from industrial, I drive like
Yeah, yeah.
20 miles,
Hold on a second.
30 miles,
Hey, Vatsin, I'm going to return back to you. Hold on a second. Okay, Vatsin, did you have any questions?
Um, yes, but I'm not sure if this is the right place to ask. Basically, I'm facing a problem with something that I'm trying to build. I don't know if I should ask you right now or in your office hours.
You can ask me on your office hours if you find it comfortable.
Okay.
Yeah, I
So
mean,
I'm
yeah. You can ask me on your office hours if you can ask me right now also. But yeah, you're on speaker, so it's better you can ask me on my office hours. Okay.
okay. I mean, I don't really mind if I'm on speaker. So is that
That's okay.
fine?
That's okay. Then you can ask me, ask me the
Oh,
question. It's okay. Yeah.
that's great. So, okay, I'll quickly explain the setup. I have an ESP32 and I have a motor, right?
Okay.
So I
Yeah.
have the motor encoders, the two wires connected to interrupt pins on the ESP32.
Okay.
And I have a timer because I used to work at a controls company before this, and what we used to do there was we had a timer which ran the whole control system, right?
Yeah.
Yeah. So I'm trying to do something like that, and it doesn't matter what um, frequency I use on that timer. Like I had like that timer obviously throws an interrupt, right? So I had a 1 second interrupt on that, and when I like turn the motor while that interrupt also goes off, the timer interrupt, it makes the CPU panic. Um,
Panic. What do you mean by panic?
yes, like it just crashes and it reboots the whole thing. The
Oh, okay.
Yeah, the ESP32 error logs call it a core panic. Now, I'm not sure what I can do about this. I've been looking online.
Okay. Yeah, it's totally out of the out of the syllabus.
Yes.
Question did you did ask? I'll think about it once, but I don't know whether. I mean, I need to see the memory that you're using, the amount of memory that might be you might be using, or how many. Uh, uh, you might have a timer, and you might be running a lot of information on it, as a result of which the system might be getting overloaded. So that might cause the system to hang. Is it hanging and it's you're not able to close the system? Is something like that?
No, no, no. So the thing is, I thought about that as well. So I completely removed everything from the timer and I just like incremented one variable, which should not be an issue, especially on a 1 second timer.
Okay.
But what I'm thinking, right? So when it says it panics, right? It just reboots the whole system.
Okay. It reboots the processor. Okay.
Yes.
Yeah. Okay. That's a good clue. Let me think about it once. Since you're talking about ESP32s, uh, I need to look at the data sheet once. Uh, yeah, I'll get back to you on this if that's okay.
Yeah, that's totally okay. Thank you so much. I might contact you in your office hours again.
Cool.
Right,
Okay,
thank you so much.
see you, Watson. Hope this helps. Yeah.
Yeah, thank you.
Fahad, did you have any questions?
No, actually not. I actually want to know the class timings and all because this is my first semester and this is my first class and it's in person or it's online because it says it was a hybrid, so I didn't got any Zoom links. I did find this on the course.
Yeah, so the class timings are 4:30 to 7:15 on Wednesdays. So, and you don't need to come in person, but I would strongly encourage you to come in person so that you might have we might be having discussions, we'll be having questions answered. So it is thoroughly encouraged for you to attend the class, and however you can attend it on Zoom. Uh, the Zoom link is given on your modules, and after the the class discussions will be recorded, and it will be available to you on your spreadsheet. Is that okay?
Okay. As for laboratories and all that things also, it's on Zoom and or it's like in person.
So the labs,
Yeah,
uh,
the labs.
we don't have different lectures for the labs. If I need to do a walkthrough for an experiment, I'll discuss it during the class. For the TAs, the TAs will be present in the labs. You can go in person, or you can ask them via Zoom. They'll have their Zoom link available on Canvas. You can attend it via Zoom, or you can be present in the lab, which is GWC 379, and you can ask them your questions. You can run the experiment on the lab itself also.
Okay. As for today's class, what we are going to do, like I need to stay, right?
No. The class today we did talk about the entire course material.
Okay.
We went through the entire syllabus, the grading schemes, the points that are the points that are allotted for the assignments, quizzes. So yeah, uh, today's class was basically introduce the course material to you. Then from the next class onwards, we'll be talking about homework one, and then some of the quiz questions. So yeah, okay.
Okay, I'll be personally visiting the class because I actually have the class there and it's nearby. So I'll personally visit the class in person, attend the class in person.
Sure.
That will be good.
Okay, yeah, I'll be seeing you.
So, and as for the classes which like like first class I missed, so there will be a recording posted on modules, right?
Yeah, so hold on a second. Hold on a second. Yeah, can you see my screen?
Yeah, I
Yeah,
can.
so go to modules. You will see class meeting Zoom recordings
Yeah.
here. And you can go to the spreadsheets, Google spreadsheets. That is the link that is given to you. For
Okay.
today's recording, the Zoom link will be mentioned here, and the passcode will be given here so that you can have access to the entire recording. Does that make
Oh,
sense?
yeah, I got it.
Okay, yeah.
Thank you. Thanks for this.
Okay. See you, Fahad.
Uh, See.
Hold on a second.